In this video, I will be discussing the use of chemical formulas to relate the mass of substance to the number of atoms, molecules or ions contained in the substance, a relationship that leads to the crucially important concept of the mole. Interconverting masses, moles and number of particles. The mole concept provides the bridge between mass and number of particles. As you can see here, the number of moles of the substance is central to the calculation. 1 mole is defined as 6.02 10 to the 23 objects. These objects can be atoms, molecules, ions and so on. So 1 mole equals 6.02 10 to the 23 atoms, molecules, ions and so on. So this is the Avogadro's number, and Avogadro's number can be used as a conversion factor to calculate the formula units. So if you know number of moles, then you can use Avogadro's number to calculate the formula unit. Then molar mass is used to calculate the mass of the substance. So molar mass here is acting as a conversion factor between moles and grams. Molar mass is the mass of 1 mole of substance. The unit is grams per mole. Most of the periodic table shows the atomic mass of all the elements. As an example here, if you take oxygen, so the molar mass or the atomic mass of oxygen is given here. For oxygen, it is 16 grams per mole. Let's see how you can calculate molar mass of compounds. Potassium chloride. So potassium has a mass of 39.10 grams per mole, and chloride has, or the chlorine has 35.45. So the molar mass of potassium chloride is the 74.55 grams per mole. That means if you take 1 mole of potassium chloride, the mass is 74.55 grams. Sodium sulfate. So sodium has mass of 22.99 grams, and there are 2 sodium atoms in this compound. Therefore, you have to multiply this by 2. This mass is for sodium. You are going to add that to the sulfur, 32.07 for sulfur. And then oxygen 16, and you can see there are 4 oxygen. So you take the mass of oxygen, multiply that by 4. That gives you 142.05 grams per mole. Next one is calcium carbonate. Calcium has a mass of 40.08, and you have carbon in there, which is 12.01, and oxygen, there are 3 oxygens, so you have to multiply 16 by 3 to get the total mass of oxygen, which gives you total as 100.09 grams per mole. Next, aluminum nitrate. Aluminum has a mass of 26.98. And then you have 3 nitrate groups which contains 3 nitrogens and 9 oxygens. So this 3 is for nitrogen as well as for oxygen. Therefore, there are 3 nitrogens. You take the mass of nitrogen, multiply that by 3 to get the mass of total nitrogen. That add to the oxygen. So 3 times 3, there are 9 oxygen. So 16, the mass of oxygen, multiplied by 9 because there are 9 total oxygens. So when you are adding numbers, you have 3 nitrogen, which gives you the mass of 42.03, and there are 9 oxygens, which gives you 144. So the mass of aluminum nitrate here is 213.01 grams per mole. Now you know how to calculate molar mass of substances. Let's see how you can use molar mass as a conversion factor. Calculate the moles of zinc nitrate in 287 grams of this substance. You are given all the molar masses here for the elements. Let's see how to calculate the molar mass of zinc nitrate. Zinc has a mass of 65.38, and there are 2 nitrogens, so 14.01 times 2, and there are 6 oxygens, 16 times 6. Total mass here is 189.4 grams per mole. The mass is given, which is 287.0 grams. And then let's see how we can use the conversion factor here. We need number of moles, therefore your moles should be at the top, and then your denominator is 189.4 grams. We use grams here to cancel out grams and grams, and you will get your answer in number of moles. When you do the calculation, the calculator tells you 1.5153, like that few numbers. However, again, when you are doing calculations, you always need to know that the correct number of significant figures. In the given number here, you have 1, 2, 3, 4 significant figures. Therefore, your answer will take that 4 significant figures. With 4 significant figures, your answer is 1.515 moles. Calculate the mass in grams of 0.030 moles cadmium sulfide. So in this question, you are given number of moles, and we are going to convert that into grams. To do that, we will use the molar mass of cadmium sulfide as the conversion factor. Let's calculate the molar mass. Cadmium sulfide, the formula is CdS. So in cadmium mass is 112.41 grams, and then sulfur is 32.07. Altogether, the molar mass of the substance is 144.48 grams per mole. Now you have 0.030 moles of cadmium sulfide, and I will use my conversion factor here. 1 mole of cadmium sulfide is 144.48 grams. Moles and moles will cancel out. You will get the answer 4.3344 grams. So when you do this in the calculator, this is the answer you will be given. However, in this case, you have only 2 significant figures. Therefore, your answer should contain only 2 sig figs, which is 4.3 grams is the correct answer with correct significant figures. Avogadro's number. Avogadro's number is the number of particles in 1 mole. 1 mole defined as the number of atoms found in exactly 12 grams of carbon-12. So if you take 1 mole of any substance, that equals to 6.02 10 to the 23 atoms, molecules, ions, or we can say particles. Whenever you have number of moles, you can calculate number of atoms, molecules, ions or particles by using Avogadro's number as a conversion factor. The same way, whenever you have number of molecules, molecules, you can calculate number of moles in there. Let's see how we can use this Avogadro's number as a conversion factor. How many molecules are there in 2 moles of carbon dioxide? So we just discussed 1 mole of substance contain Avogadro's number of atoms, molecules or particles. In this case, 1 mole of carbon dioxide contains 6.02 10 to the 23 molecules. We have 2 moles given and asking you to calculate how many molecules are there. So 1 mole of carbon dioxide contains 6.02 10 to the 23 molecules, and we multiply that by 2 moles of carbon dioxide. So moles and moles will cancel out, and you will get 12.04 10 to the 23 with the correct number of significant figures in scientific notation 1.204 10 to the 24 molecules. This is your answer. So we use Avogadro's number to convert number of moles into molecules here. Then, how many oxygen atoms are there in 3 moles of water? So if you take 1 mole of water, you have 1 mole of oxygen. Right? So that means you have 6.02 10 to the 23 atoms of oxygen. So it's asking you to calculate how many oxygen atoms are there in 3 moles of water. So in 1 mole of H2O, you have 1 mole of oxygen. And we will calculate how many oxygen moles in 3 moles of water. So in 3 moles of water, you have 3 moles of oxygen. To calculate the atoms, so you multiply this by Avogadro's number. Depending on the question, you can change this word atoms, molecules, ions. So in this question, it's asking atoms, so we use atoms here. So your answer is 18.06 10 to the 23. You can write this in scientific notation 1.806 10 to the 24 atoms. How many sodium ions are present in 0.5 moles of sodium chloride? So sodium chloride is a strong electrolyte. So you can write this equation whenever you have sodium chloride solution, you have sodium ions and chloride ions. If you have 1 mole of sodium chloride, you have 1 mole of sodium ions and 1 mole of chloride ions. So first we will calculate how many moles of sodium ions in 0.5 moles of sodium chloride. So 1 mole of sodium chloride gives you 1 mole of sodium ions according to the equation here. And then we have 5.5 moles of sodium chloride. We calculate the moles of sodium ions here, which is 0.5 moles of sodium ions. As we discussed earlier, 1 mole of any substance contains Avogadro's number of molecules, particles, ions or atoms. So in this case we are talking about ions. Therefore 1 mole of substance containing 6.02 10 to the 23 ions, and we have only 0.5 moles of sodium ions here. So this gives you 3.01 10 to the 23 ions. So when you have 0.5 moles of sodium chloride, you can obtain 3.01 10 to the 23 sodium ions. Next, how many atoms are there in 5 grams of magnesium? So we know Avogadro's number has a connection between moles and atoms, molecules, ions or particles. Now you are given grams. So we have already discussed about the molar mass. Therefore, this should be first you take the grams and then convert that into number of moles, and then you can calculate how many atoms are there. Since there are no direct conversion between grams and atoms, you have to go through number of moles. So let's take the given number. You have 5 grams of magnesium. My first step is to convert this into number of moles. So 1 mole of magnesium is 24.31 grams, which is the molar mass of magnesium. In this step, you will calculate moles of magnesium you have. This gives you 0.2 moles. Then you take the number of moles, 0.2 moles, convert that into number of atoms. So we will use Avogadro's number as the conversion factor. 1 mole of magnesium is 6.02 10 to the 23 atoms. Moles and moles will cancel out. You will be getting 1.204 10 to the 23 atoms. In this video, we discuss molar mass, Avogadro's number. Both of them can be used as conversion factors in order to calculate grams, number of atoms, molecules or particles. So if you have any questions, please write them in the comment section. Thank you.